All right, let's get a little bit more formal in our definition for a function. A little bit, because I'm not going to give a full definition, but a much better definition. So a function, and functions are also sometimes called maps. So a function or map is written like this. It's f. It's defined from some domain A to some codomain B. All right, so again, here A will be the domain. B will be the codomain. It's where the outputs lie. All right, so that's the function, and we have f of A is B. You could also write f of A, the image of A, is some set B. So you can do this for elements or sets in this case as well. And these are going to be the images. Right? Those are some images, as you can write. And then specifically, we also want these to be non-empty. We don't want empty sets here. Not going to have functions with the domain or the codomain being the empty set. That would be boring. It'd be very silly. Finally, the output must be unique. And now this part should be pretty familiar for most people. One input can only go to one output. An input can't go to multiple outputs, just like the functions that you all know and love from pre-calculus. So let's work with these. Let's use these a little bit with some examples. So consider the function f. Not particularly creative in what we name our functions here. F is a set of all letters in the alphabet. Oops, that's not how you spell alphabet. All right, the letters in the English alphabet anyway. And let's say that, F is not the set. That's the domain. F is the function that takes elements in that domain to the natural numbers. So this is our domain. This is our codomain. All right, and the question is f a function? Oh, and oh my gosh, I'm really out of it. Before we ask if f is a function, I have to really tell you what the rule is. So I've declared the function, I've given you the domain, I've given you the codomain. I just have to describe the relationship, the relation here. So this is the function f, and we're going to say that it assigns a letter to its place or order in the alphabet. So A would be assigned to 1, B is 2, C is 3, Z is 26. Okay? So the question is f a function? Is every input only go to one place? If A were to go to 1 and 5, for example, then it wouldn't be a function. But yes, here, it's a function. All right. Is it surjective? No. Because what's the range? The range of this function is just the integers from 1 to 26. The range is a proper subset of the codomain. The range is not equal to the codomain. So this function is not onto, right? It's not onto, it's not surjective, but it is a function. And later on, we'll also have similar definitions for something called injective and bijective. Bijective, you might not be surprised to find out, just means it's surjective and injective. So if it's both of those jectives, it's bijective. But I'm getting ahead of myself. So I don't want to get too formal, but I do want to mention it real quick. A formal requirement for a function, right? F is a function if every x in the domain has the image of that x, not the empty set. So what does this mean in normal English? This means, in normal English, that everything in the domain goes somewhere. This means that everything in the domain has a function value. Okay? The domain has to, like the function has to apply to everything in the domain. That's what this is saying. All right? Another way, and then this image is unique. What does that mean in normal English? That means each input only has one output. Okay. All right, let's do some more examples. Just one more example. Well, it has 3 parts. Is an example with 3 parts really just one example? I don't know. Are these functions? And what I want you to do is I want you to pause the video once I've written them all down, think about it, and see what you say. So this first one, let's say, has the letters A, B, and C in the domain. The numbers 1, 3, 5, and 9 in the codomain. And then A goes to the number 1, and B goes to the number 5. Is this a function? Set B has the same domain, same codomain. 1, 3, 5, 9. Here, we have A goes to 1, we have B goes to 5, and C is going to 3 and 9. And the last one is really tricky. R of x is a piecewise function where it's equal to x if today is Monday. And it's 2x otherwise, if today is not Monday. Pause the video, write down your answers, and let's see what you get. So this first one looks like a function, but it's not. Why not? Look at our 2 requirements. The domain, the function must apply to everything in the domain. Every element in that domain needs a non-empty image. C doesn't go anywhere. We have something in the domain that doesn't have anywhere in the codomain that it goes to. So specifically here, the image of the set C is the empty set. And we specifically said that cannot happen. All right, so f is not a function in this case. The second one was hopefully a little easier. The second one is very similar, but now C goes to 2 places. No. The image must be unique. Okay, C can't go to 2 places. C, I would honestly accept either answer for C. At any given time, this is a function. Now, if you wanted to say like, well, R of 2 could be 2 or 4, depending on the day, I would give credit for that. But I'd say at any given time, this is a function. But again, I wouldn't actually ask this question because I think it's a little ambiguous and I think you could argue either way. All right, you could say, yeah, 2 goes to 2 different places depending on the time. So that's a fun little problem that I saw in the book that I wanted to talk about because it could go both ways. That's this video. Let me know if you have any questions and good luck.